Since the beginning of the human story, the stars, planets, and the dazzling Milky Way have been a constant presence in the night sky.
They have helped us navigate the oceans and chart time, and they have inspired great works of art.
But worsening light pollution means the glories of the night sky are now hidden from many of us.
In this programme, we'll be looking at the impact of light pollution, not just on astronomy, but on life itself.
And we'll also be discovering how to work around light pollution, lessen its impact, and looking at ways to provide beautiful dark skies for future generations to enjoy. Welcome to the Sky at Night.
Here in London, a new attraction is the Van Gogh experience.
Oh wow. We're here to experience one of the artist's most famous paintings, Starry Night.
Well, this is impressive, isn't it?
This is amazing. It's like being inside the picture.
Yes. I mean, I think it does portray that. It gives you the impression of being out under an impressive stellar sky and your mind whirling because of what you're seeing.
Yes. I think he drew this when he was actually in an asylum suffering from depression. So I'd like to think of this as the antithesis. You know, he's in a horrible place, but this is where he'd like to be.
Yeah, looking out at the universe. And I like the fact it's a real night sky, though obviously it's not a technical drawing. It's swirly and impressionistic. I think that's Venus up there, the crescent. I think it must be. So I like to think this is actually what he was seeing from outside his window.
Just seeing it makes me feel quite peaceful, and that's what seeing the night sky makes me do. It just sort of relaxes me, and I think we need more of that.
I think what's interesting is you can imagine a modern version. You'd have to light the church and put streetlights in. It's very hard to experience being under a dark sky like this.
Ever since industrialisation, astronomers have complained that the night sky isn't as dark as it used to be. But over the last decade, we've been able to combine satellite data with ground observations to quantify the problem.
And it's not just astronomers who are interested in the data. Chris spoke to Kevin Gaston, a biologist at the University of Exeter.
Well, Kevin, thank you for talking to us. What do we know about the conditions of our skies? How bad are things?
I think we're learning very quickly that they're much worse than we imagined. Something like 80% of the world's population is living under light polluted skies, and that's nearer to 99, 100% of the population in Europe.
Is there a way of quantifying what's going on? Can we say something about how bad things are and whether it's getting worse or getting better?
If we just take the raw data that satellites are directly measuring, we estimate that between 1992 and 2017, so about a 25-year period, emissions have grown by about 49%. But as we undergone sort of lighting technological revolution, bring in LEDs, which emit much more in the blue very commonly, we've had to explore ways of, if you like, adjusting the calculations to understand just how important and significant those blue emissions are. The satellites that have been used over the last 25 or more years have been very limited in their detection of emissions in the blue.
So that sounds like things are worse than we expected.
If we then adjust for the bits in the blue and the shift to LEDs, that's at least 200%, 270%, and maybe a lot more than that. So we've been quite drastically underestimating what's happening.
Obviously it matters to astronomers because we want a view of the sky, but there's a broader issue here. Why does light pollution matter?
Biological processes and their timings are foremost driven by two things. They're driven by temperature and they're driven by light. And what we're doing here is we're messing around with those light signals. So it affects organisms' physiology, it affects their behavior, it affects where their ability to know where they are in the season. And those have impacts on reproduction, on mortality, and therefore on populations and communities. And these things just ramify through ecosystems.
If we're influencing the natural world, then presumably do humans suffer similar effects?
I think our psychology, in terms of kind of our place in the scheme of things, I think it's something astronomers have kind of perhaps thought about more than many others. There's also those impacts on physiology, and there's lots of concern around how that might feed through to impacts on mental well-being, on impacts on potentially cancer risks and stuff.
But what do you think we should do in terms of rules for lighting? Are there things we can do that are plausible?
Lighting is one of those things that we could change very quickly. We have a lot of nighttime lighting that persists all night long, when actually there aren't many people who are using it. And actually we could exploit sort of more responsive technologies that actually light things when you need it.
Well, I think this sounds like an excellent idea. So Kevin, thank you very much.
For all the reasons Kevin describes, it's becoming increasingly obvious that we need to work on reducing light pollution and protecting the few pockets of dark sky we have left. Pete met up with Dark Skies officer Dan Oakley in one of those dark spots known as Moore's Reserve, after our very own Patrick Moore.
So Dan, we're in this fantastic location here. Where exactly are we?
We're in the South Downs National Park.
Okay.
We're at a site called Old Winchester Hill, and you can see all around us we've got this lovely rural landscape, but we've got lovely big cities all the way to the south that provide us with all the light pollution. Portsmouth is about 15 miles away. We've got Gosport,
Yes.
all the way around to Winchester, which
Right.
is over that hilltop over there. Got Basingstoke, and up towards the north we've got Guildford, and a bit further you'll see London as well.
Right, okay.
And although our reserve has a central core area, which is where we find the darkest skies,
Yes.
we've actually got little pockets of dark skies all the way along the south coast that even touch onto the iconic Seven Sisters Cliffs in the far
Right.
east. And you can get the same experience there. So it's not all about protecting the core. For us, it's about protecting any bit of dark skies
Sure.
across the South Downs.
So in order to meet the dark sky reserve criteria, how dark does it actually need to be? Is there a value that you measure?
So we have to use a sky quality meter.
Oh, yes.
Which is a little device that I point to the sky, and it measures the brightness in a small patch of the sky.
Right.
Converts it to a number, compares that to the Bortle scale, and from there we can compare ourselves to other sites worldwide.
Okay.
I mean, we're definitely level 4, which is a rural, and as you can
Right.
tell, we are properly rural. But we're a good rural sky. We know we can see the Milky Way here, which is the important thing
Oh,
for
that's
dark sky.
amazing, yes.
So I mean, that's where people start their experience from. So all these people on the south coast, they've got half an hour and they can come and see their home, the Milky Way. And
That's
get
pretty
started.
amazing, yeah.
Yeah.
I should explain that the Bortle scale it's a 9-grade scale, isn't it? A 9-point scale where 1 is ridiculously dark and 9 is what you get if you were living in a city. So 4's pretty good.
4's good. I mean, I'd love to be a 3, but there's just too many people living here, which is great because they can enjoy it. And
Yeah.
For me, it's the experience rather than the absolute measure, I think.
Well, I'm really excited to come back and have a look at the sky when it's dark tonight. So hopefully the clouds will disappear and we'll get a view of the stars.
Yeah, no worries. See you later.
Well, it's dark, Dan, but the clouds haven't gone away, unfortunately. But, in a way, that's helped us to see just how special this site is, because you can see the light pools around us, can't you, quite clearly?
Yeah. For us, it's all about the relative differences. So you can see all the light, all the light pollution from all those different sources coming off the clouds. But as soon as you stop that move away from the urban environment, coming to the rural, you can see that the density of housing goes down, the amount of light pollution goes down. So this is what we're trying to protect. It's kind of this buffer zone between the urban and the rural. So that's why keeping this is very, very important dark, because it's protecting the night sky above our head.
Now, the International Dark Sky Association requires you to have a certain value of darkness to the sky. And you were mentioning earlier about your dark sky meter. Have you brought it with you?
Yes, I have. It's right here. Yeah, it's one of the handheld versions. So it's
Right.
just a a nice easy thing with one button on it, and we just basically just press it up to the sky.
Yeah.
And it gives us a reading 17.56. Now that's not particularly dark because
Because you've got clouds up here.
Yeah,
Yes.
so we'd expect to see about 20.5. And
Right.
that's actually the point where my eyes can pick out the Milky Way quite well. And this is the thing you've got to do for your IDA requirement. But the trouble we had as a national park in the south is we didn't think we were dark enough.
Okay.
And when we compared ourselves to places like Exmoor, who went before us,
Yes.
they kind of know they're dark because they've got big areas of open wilderness. So we took a different approach by taking a GPS version of this, sticking
Right.
it on the side of a car, and then I just basically drove around the South Downs for 3 years at night, late into the morning, taking all these readings, and from that we developed a lovely colourful map of where all the sky quality was, and that
Wow.
map we now use for planning purposes and gives us a good way to implement the policies a bit more smarter.
So how do you go about keeping this in place? Do you need to have legislation in place to make people obey the dark sky requirements?
Well, I mean, we've got the planning law, which does a certain extent, and we have environmental nuisance laws as well.
Yeah.
But I think from the authorities' point of view, we like to engage with our community, so I think it's important that we get those messages, and they're really simple messages. So, you get a lot of questions about how I can do my garden light and make it better.
Right.
And we just tell people, do the basic 101 for light pollution is make sure the light's going where it's needed and not up into the sky.
Yes, yeah.
And you'll see that kind of principle in all the good street lighting. So a lot of the places on the downs, like I said, the lighting authorities of Hampshire, West Sussex and East Sussex, all their street lights make sure the light goes down. And if it's not going up into the air, we get to see more stars. When we submitted our application to the Dark Skies, the little motto I gave the application is, we may not be the biggest, we may not be the darkest, but we will be the most cared for. And I think that's right. We've had communities all along the South Downs, even outside, even communities in Brighton, wanting to do their things to help cut out light pollution. So
Right.
the messages were there, and it's slowly getting embedded.
It's spreading
into
out, yeah.
Which is brilliant. It's exactly what we wanted to do. It's exactly the point of a reserve. It's getting those principles embedded in all levels of society.
Well, I think the Dark Sky Reserve is a fantastic testament to the amount of work you're all doing, and it's incredible. I actually find it lifts my spirits to know this is happening and it's spreading out. It's just superb. Brilliant job, fantastic.
Yeah, thanks.
Around 80% of us now live in bright urban areas, and many have to travel significant distance to experience dark skies like these. But that doesn't mean you're out of luck. Chris went to meet a group of astronomers who are determined to show that wherever you live, you can still enjoy the night sky.
Astronomy group the Baker Street Irregulars have been preaching the gospel of inner city astronomy for over 10 years. But here, at Television Centre under bright West London night skies, it's easy to be sceptical.
Well, gentlemen, I've observed in some ridiculous places for the sky at night, but I think this wins the award. What are we doing here? Why are we in the middle of London trying to look at the sky?
Well, we just want to prove that good astronomy can be done from any location regardless of the conditions. And it doesn't matter if you're in the middle of a city, it doesn't matter if you're in the middle of the light pollution, good astronomy can still be done, no problem. So we just offer to prove this.
What are the simple tips for people who want to observe with the naked eye from the middle of a city? What can you do to help?
Well, one thing that you can do is move away from local light pollution. So don't have any lights immediately in your surroundings or go into a relatively locally dark area. Dark adapt your eyes.
Get used to being outside in the dark.
Absolutely, yeah. Take somewhere between 20 and 40 minutes for full dark adaptation, and you'll see a lot more.
You three and your group have been really ambitious. So what have you gone on to do from inner city skies?
From inner city skies?
Yeah.
I mean, we've all branched out in various directions, which is why we've got a little group here today. We have ISS imaging here, we have people who like night vision devices.
Yeah. Well, let's go in order. Let's talk about the space station, because I think there's something about seeing the space station in the sky and waving at it that really appeals to people. But you've taken it much further than that.
Yes, it's definitely, I think, one of the brightest objects in the sky one can observe. wherever you are, whatever light polluted city you are living in.
You said you photographed it as well. How do you go about doing that?
I had to experiment myself because there are no descriptions or recipes that how you need to do this. So I had to experiment a bit. But it's a telescope and a high frame rate camera.
And swinging across the sky
exactly.
as well.
It's manual tracking.
Do you have a particular favourite image that you've captured or a particular pass of the space station that sticks in your mind?
There are a few, but if I probably have to choose one, it was last year I had a birthday present. The ISS just went in front of the moon, and even Chris Hadfield, the astronaut, shared it on Twitter. So,
nice. So you managed to capture a photo of that?
Yes.
From here in London?
Yes, it's an animation because we're taking high frame rate camera videos. It means that you can actually see it zoom past him.
Can we see it here?
You can even see some of the spacecraft that dock to the International Space Station.
Yeah.
Very often, if you go out at night in the early evening, all of the planets are so bright, they will be out before any of the stars. So from an urban location, very, very easy to identify. I mean, we have one taken of Venus here, but in this case we've used an ultraviolet filter and combined the normal white light images with the ultraviolet so we can get some cloud detail there.
Filters are part of this game. If we're doing city astronomy and city astrophotography, filters are really important.
Very much so. If you take a look at here, here we have the Andromeda Galaxy. This shot is taken unfiltered and unprocessed, but if we show you the same picture once filters have been applied and it's been properly processed, you can see the sky now has gone back to black, nice and dark. You can see all of the stars behind it. You can see the dust lanes, everything.
That's a beautiful shot. And we should say, when we say filter, this isn't a Photoshop filter. This isn't something in the computer.
No, it's a
this is a filter
filter
on the telescope that stops the light pollution getting into the image.
Absolutely.
I have to say, I stare at a laptop most of the day, and so when I come and want to use the telescope, I want to look through it. I'm a visual observer. Gavin, is there anything we can do to rescue that experience from the middle of a city?
Right, yes, there is, and that's obviously my passion, is live visual observing. What I use is to help me is this device you see here, which is a night vision monocular used by the military.
Okay.
And this actually intensifies the light by about 60 to 70,000 times.
So in films, this is where you see them look and it's all green and people are running around in the woods,
yes,
sort of thing.
Exactly, but this one is actually white, so it's a more natural looking there. And that's one of my favourite nebulae, the Rosette Nebula.
So let's look at this. The structure in this image is just lovely. So that's through a telescope with this enhancing night vision device.
And if you know what you're doing, you can achieve spectacular results. These might look like pictures from the Hubble Space Telescope, but they're actually the work of a member of the Baker Street Irregulars, taken from right here in light-polluted London.
Well, it's brilliant and important work that you're all doing. Keep it up, and let's enjoy the sky wherever we are.
You're welcome.
Thank you.
Well, hopefully we've convinced you that even from a rooftop in a city, there's plenty to see in the sky. So to tell us what to look out for, here's Pete.
Well, it's still cloudy here at the Moors Dark Sky Reserve, unfortunately. But if it were clear, at the time we're filming this, Orion would be just below the horizon for me. But by the time you're watching this, Orion will be well placed in the southern part of the sky. And Orion is a fantastic constellation, regardless of what your sky quality is like. If you live in the city, you can only make out the brighter stars. And that actually helps you, if you're a beginner in astronomy, picking out the main pattern, because you haven't got the fainter stars to confuse you. If you've got slightly darker skies, you should be able to make out the faint line that runs underneath the belt of Orion, and that's Orion's sword. If you've got binoculars or a small telescope, then have a look at the sword. Right in the centre, you should be able to make out a misty patch, which is the Orion Nebula, Messier 42. Now, if you look up at the belt again and use binoculars, you should be able to make out some fainter stars around that. And the reason for that is that this is the region occupied by an open cluster known as Colander 70. Now, you can use the belt again to good effect because it's a good measure, a sky ruler if you like. You basically identify the line made by the belt and then look at the star on the left-hand or eastern side of the belt, that's Alnitak, and imagine that's a pivot point. Then if you rotate the belt by 90 degrees in an anti-clockwise fashion around that point, Where the free end ends up, that points to Messier 78, another region of nebulosity. Now, I like this region. If you look at it with a telescope, you'll see that there is some mistiness with two bright stars in there. It always reminds me of car headlights coming towards you in fog. Now, if you go back towards Lintott, that's the star on the left-hand edge of Orion's belt, and you've got slightly darker skies still, you should be able to make out an area of nebulosity just to the east or the left of that star. And that's another nebula known as the Flame Nebula, NGC 2024. Now, the problem with viewing the flame is that Lintott is a really bright star, and you get natural light pollution from that star, which ruins your view, so it's quite difficult to see. Now, the next object is really quite tough, and you need to have really dark skies, a big telescope, or an astrophotography setup to see it. Because running south from Lintott is a curtain of nebulosity. That's known as IC 434. Now, to the east of that curtain, there are fewer stars. And the reason for that is there's a big dark cloud blocking the way. Now, there's a finger of that cloud which sticks out in front of that curtain of nebulosity. And that finger forms a silhouette which looks exactly like the profile of a knight piece from a chess game. And that's known as the Horsehead Nebula, or Barnard 33. But that is a really tough target to see visually. Now, if you have really dark skies, then consider taking a wide field photograph of Orion, a long exposure wide field photograph, because then you should be able to make out Orion's alter ego. There's a huge loop of nebulosity that surrounds the main pattern. That's called Barnard's Loop. And around the stars which form Orion's head, there's another circular patch of nebulosity. And that's the Lambda Orionis Nebula, or the Angelfish Nebula. Now, those two circular features taken together give Orion his alter ego. He looks just like a giant snowman in the sky.
Now, as anyone who's taken a long exposure photo of the heavens will know, it's increasingly common to have your picture ruined by streaks of light produced by orbiting satellites. But this form of light pollution is nothing new, as Maggie has been finding out.
In 1997, the Iridium program was born. The dream was to start a new era in mobile telephony using satellites. Imagine great connectivity no matter where you are in the world. But there were problems. Firstly, the Iridium program needed a lot of satellites. And secondly, each satellite had a large antenna, which was highly reflective. The early satellites caused an Iridium flare, a novelty in the night sky that was enthusiastically photographed by some, but which was a visual nuisance to others. The trouble was, the 66 satellites worked like a dream, a technological triumph. And now, the idea has been replicated on a massive scale. SpaceX and others are in the process of installing 42,000 satellites into low Earth orbit. These mega constellations will provide internet to remote areas. The impact that these thousands of satellites may have on optical observations is easy to appreciate, but other forms of astronomy are also in danger, as I found out from Tim Stevenson from the Square Kilometre Array Observatory.
Hi Tim, it's lovely to speak to you. And we've got this glorious image, an artist's impression of the Square Kilometre Array. But can you tell us what it's going to do?
The two telescopes will be the two largest radio telescopes ever built, and size matters when it comes to radio telescopes. You get higher resolution and you get greater sensitivity. So we're exploring a larger region of the universe than we were before.
So what sort of things can you pick up with radio astronomy?
You can explore both the structure and evolution of our galaxy in very, very high resolution, but also the structure and the evolution of the broader universe.
We've been talking about sort of optical telescopes and the challenge of sort of having dark skies and light pollution. Do we have similar problems with radio astronomy?
5 years ago, most of the emitters that would cause us problems from space were stationary in the sky, geostationary. So you could avoid them, you could look around them, you could look past them, so to speak. But now the two constellations, the mega constellations that are deployed at the moment, they are radiating about 13 gigahertz. So for us, that sits in our band 5B. Now it's much more intense, and the sources are rapidly moving.
Tim, you mentioned this 5B waveband, and you mentioned that it's vulnerable. Can you tell us what it gives us?
So carbon monoxide, which is an important indicator of the general gas concentration in stellar forming processes and galaxy evolution and so on, at certain distances we can't see it because these spacecraft are radiating very strongly in those bands, and it blinds our telescopes.
Yes, so you're swamped by the local signal coming from these satellites. So this sounds like a real challenge, but can anything be done about it?
But the most obvious thing for us to do is to deal directly with industry, appeal to them that we have a problem, and get their cooperation. Now, we work with them in understanding their system and their commercial imperatives, and negotiate with them to minimize the amount of radio frequency power that we see on our sites.
So you're not talking about sort of shifting the frequencies to somewhere else. You're talking about sort of effectively sort of turning the satellites off when they're over certain areas? Or?
Yes, that's exactly right. You can't shift the frequencies because effectively these mega constellations operate within ITU rules, and they're only allocated certain bands in which to operate.
So, Tim, I guess one of the problems is these constellations of satellites are trying to provide internet to rural areas, and you build radio telescope in rural areas to get away from the noise. So aren't these two things in conflict?
Yes, indeed they are. But part of it is already resolved because our telescopes are in radio quiet zones, as they're called, and these radio quiet zones are established by law. The governments of South Africa and Australia, respectively, have actually made it illegal to operate radio equipment in these zones. But they are rural, and in the case of South Africa, underdeveloped areas. And the communities within these areas would benefit very much from improved internet connectivity.
Well, I hope the negotiations go well. And as you say, we're all scientists and engineers sort of working together, so hopefully solutions can be found. Thank you so much for speaking to me today.
Thank you.
Through this programme, it's really been interesting to see how light pollution is affecting everything, really.
Yeah, it's a serious problem. I think we think of it as an astronomical issue, but it affects how people sleep, their mood, it affects wildlife, and the problem's getting worse. But I think there are solutions. Technology means we can be smarter about lighting. We can put light where we need it, when we need it, rather than just lighting up whole swathes of a city just because that's easy.
Yes, and the thing is, environmentally, that makes so much more sense. But with light pollution as well, it's not just affecting us, it's affecting everything, sort of wildlife all over the world.
Yeah, and maybe we should look up at the sky and be reminded that that's worth preserving. People want to go and see the northern lights. People want to, at some point, go and sit under a dark sky. I think it's good for people to get out and look up and see something spectacular. For all that you could do astronomy in a city, there's nothing like being in a properly dark site, looking at the kind of view that Van Gogh was enjoying. That's all for this month, and so until next time from this starry night.
A happy new year to you from everyone here at the Sky at Night. And as always,
good night.
See things no eye has ever seen. The Green Planet is available to watch now on BBC iPlayer. And on BBC Sounds, how the jellyfish is the inspiration for a new robot. It's one of 30 animals that made us smarter. Listen now by downloading the app.